Alright, hackers and hackerettes, welcome to the very first video in our series, Computer Fundamentals, which is part of the pre-security path. If you haven't been watching these, I do have a playlist called Pre-Security Path, which you could check out for previous modules. The latest one before this one was how the web works. And I'll be doing a new playlist for this called Computer Fundamentals. But if you want to watch all of them in sequence with all the modules, you can check my pre-security playlist. So let's get into it. In this series, I guess, or in this like learning path, we'll be going over computer fundamentals and how computers work. Welcome to the first room of the computer fundamentals module. Before we can talk about security, we need to understand what we are securing. Consider the following analogy. Before protecting a castle, we need to know the layout of the castle, where the treasure room, the food storage, and the commander's quarters are. We need to know who enters and how they enter the castle. Also important is who can enter these rooms and take or put treasure or food, for example. The bottom line is, trying to defend what you don't understand is like defending a castle you have never seen. In this room, we'll explore our castle. We will cover what a computer is, its building blocks, and how they are connected. After completing this room, you will have a general idea of how the components of a computer system interact with each other to provide services to its users. Don't worry about too much technical jargon or depth. We'll take this nice and easy and focus on the fundamentals. Our learning objectives: after completing this room, you'll be able to recognize and understand the functions of various computer components. Okay. Motivated to step into the digital world of computing. Prerequisites. Cool. Let's get into it. Inside a computer system. Nearly every computer system that you think of includes, in one way or another, the same building blocks. Each part has its own job, and together they make the computer work. Let's have a look at each of these building blocks. One sec, I'm just adjusting my AC for this part. Okay, so the very first thing that we have is the biggest thing, motherboard, the skeleton and nerves. And then you have in there the RAM, which is the short-term memory. RAM usually goes onto these slots right here. PSU, heart and lungs, it is essentially your power supply unit. RAM stands for random access memory, by the way. I should be mentioning these. PSU is power supply unit. It is essentially what gives power to your machine or to your system. You do have a lot of cables coming out of it, each having like specific voltages and electricity, like a certain amount of electricity. I don't want to use electrical terms like voltage and ampere, like stuff like that. So I'll just use electricity as a common term for it. So your motherboard has a big cable or like a big power connection that you connect one of these onto the motherboard, and then it powers up the motherboard, which then the motherboard itself powers up all the components on top of it, like the RAM and the CPU, which goes here, stuff like that. Then you have HDD and SSD. HDD stands for hard disk drive, and SSD solid state drive. So these are the long-term memory. These are your hard disks, essentially, like your storage space. The difference between them, HDD is slower, but can be in much greater capacity because they are cheaper to make. They are the ones with spinning parts in between. You also have SSD, which are the solid-state drive. There are no moving parts in there. So it is more expensive to make, and they are more complicated, but they are much, much faster. We are talking about 10 times even more faster than HDDs. You have your GPU with your visual cortex. GPU stands for graphical or graphic power unit, graphics power unit, I believe. Let me check the full thing. Graphics processing unit. Okay, sorry. Graphics processing unit, not power unit. Which is your essentially how you run like specific more complex animations like games is the most thing that a GPU is often like tied to. So the better GPU you have, the better game well, generally speaking, the more games that you can play, or like you can play better, but that's not entirely true, because the CPU also, or the central processing unit, is the brain, is also plays like a huge part in how you play video games, if this is what you're interested about. And CPU is essentially how your computer understands any instruction. What processes it is the CPU. Throughout this task, we will use a very relatable analogy, the human body. The image above shows the different PC components and its human counterpart. To learn more about each component, open the static site by clicking the green view site button below. This should open in a split window. So we have one right here, and then you have the motherboard. What role does the motherboard play in a computer? It connects and allows communication between all components, stores data. Yes, it connects and allows connections, of course. So if you want to learn more about motherboards, you can check these out. I will not be going through. What do you think a CPU does? It is executes instructions and perform calculations, for sure. If you want to read more about the CPU. Oh, I forgot to click complete. Then you have the RAM. So RAM stores data temporarily while the computer is running. That's what it does. It is a random access memory. When you turn off your computer or restart or whatever, it is going to lose all of the information inside of it. But on the other hand, it is much faster than a regular like storage, like SSD or HDD. So save data permanently even when powered off. That's how, or that's what storage is for. Network adapter, it's, well, I don't even need to talk about that. Power supply electrical power to all components, so it just gives them electricity. Graphics card, it is processing and outputting visual information. And then input output. What are input and output devices used for? I don't think I need to speak much about that. So give the flag you received after completing the exercise. Inspection. Move your mouse or use tab to see which connector. Okay, so let's start exercise. So right here, the CPU. Oh, I need to drop it here. Okay. The RAM goes on these slots. The graphics card, it goes onto one of these PCI here. The network adapter is around here somewhere. Yes. The storage could have multiple locations, but usually, where would the storage be in this case? Well, let's do the other ones. So the power supply usually just supplies your entire machine. So it goes here. Input and output, it goes here. So the network adapter is probably going to be different. The network adapter is going to be somewhere around here, I believe. Where are the locations? Okay, so the storage is going to be in the SATA right here. And then the network adapter, I think it could go over here. Let's see. Verify. Congratulations. Yes. Okay. So the network adapter could also take like a PCI or I think this is a PCI adapter, kind of like the graphics cards. The power supply goes into this big connector. RAM goes here, CPU goes here. The input output is essentially where your input output is. It's called an I/O panel. Graphics card takes one of the PCIe slots right here. Your CPU is always sitting in here. And if you're building a PC, never, ever, 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 ever forget your thermal paste. Right, we got this up and running. And then we have XP boost, okay. What happens when you press the start button? Let's check now. Now that the core components are installed in the computer system, it is time to boot up the system. We can compare this to how we wake up in the morning and do a quick check to see if everything is working. Only when everything is okay do we get up and start our day. The image below shows the steps a computer system goes through before it shows you a working interface in the form of an operating system like Windows, for example. Press the power button. Firmware starts. Post. Select boot device. Start bootloader. So when we press the power button, our system, a signal is sent to the PSU to allow power to flow. Imagine our body being powered off when we sleep. Once we wake up and receive oxygen, our body starts pumping blood and boots up. Firmware starts. Continuing our analogy from step 1, once the body has started up, our core components are up and running, but our brain is not yet conscious. Like our bodies, a computer system contains firmware that allows all its components to start up. The central system that manages this is called the Unified Extensible Firmware Interface, or UEFI for short. Note, we'll often see the term BIOS mentioned instead of UEFI. BIOS does the same as UEFI, but has mainly been replaced by UEFI. BIOS, if you don't know, basic input-output system, it's a boot firmware essentially, but it is older than UEFI. Well, UEFI does the exact same thing. Unified Extensible Firmware Interface. Okay. So the step 3 is power on self-test. Now that our body is up and running, it is time to test if everything is functioning as it should. If something isn't, there will be some alarm signals. One of the routines that UEFI loads is the power on self-test, which tests if every required component is present, configured correctly, and functioning. If you don't know what this is, let me take a sip of this to explain that in more detail. Lovely. If you have, okay, I'm gonna speak about my motherboard because yours might be different, but my motherboard has like 4 small LEDs. Whenever I turn on the PC, these LEDs flash, and then if there is a problem in a specific component, the lid for that component is gonna stay on. So these LEDs usually indicate that there's a problem with the specific component that the lid is referring to. For example, when I upgraded my GPU recently, my graphics processing unit, or my video card is what they call it. So when I upgraded my GPU, I forgot to connect all of the power connectors to the GPU. So I did connect 1, but it needed 3 because it needs more power than my previous GPU. So I thought I could just remove the cable from the old one, put the cable in the new one, and be done with it. But of course, this was different. And the new GPU needed much more power than the older one. So when I turned on the PC, it just had the lid on the GPU just stay on red. So that LED just stayed on red for the GPU part. And this is how I knew the GPU had a problem. I simply just Googled if I should connect all of these cables. It turned yes, you should. And then I had a missing cable, so I had to do a bunch of crazy stuff. But essentially, I just made sure that everything is wired correctly, and I made sure that everything is good. Connected it, turned off the PC, turned it on. Of course, I had the PC off while I'm working on the GPU. Turned the PC on, and everything just flashed, and then they all stopped flashing, or no LEDs are on. So this is how I knew everything was good, and the PC put it up successfully. So the power on self-test, you could have like things on the motherboard that would tell you how the test has been processing, and then if everything is good or not. And then you do what is called a select boot device, step 4. Once our body is up and running, configured correctly and fully functional, our system searches for the location of our boot up routine to start our consciousness. In our computer system, the UEFI holds an ordered list which prioritizes on which device to look first for the boot up routine for the operating system. If you've ever set up a dual boot, like you have two operating systems on a single computer, you would know what boot order is, essentially which device you want to boot into first. And if you spam F12 to open up the bootloader in your UEFI or BIOS as you start up the PC, you would see like all of the hard drives that you have connected, or essentially you could see all of the bootloaders that you have on specific devices. Then you could choose one of them. So if you have Linux and Windows, you could get to choose which bootloader you wanna select or boot from. And then the bootloader, now that our system knows the part of our brain where our consciousness is located, it initiates the load routine to start it. Our computer system follows a similar process. On the selected boot device, the bootloader is initiated. This bootloader transfers the operating system from the selected boot device to the random access memory, so to RAM. Once the OS is transferred, the UEFI gives full control over different components to the OS or operating system. Now that we know how a computer system boots, let's have a little exercise. Cool. Press the power button. What am I supposed to do here? What happens when you press the power button? Oh, okay. Maybe I should make this smaller, I guess. So like it's easier here for us to solve. Can you see it well with my camera? Yes, you can. Okay. Maybe I should just completely remove my camera. I don't know why you care about me, but maybe it's cool. I don't know. Anyway, what happens first when you press the power button? The operating system starts loading. The PSU starts delivering power to the components. The hard drive starts spinning. Of course, it is the PSU. Whenever you click, you send the signal to the PSU, and the PSU lets power flow. So what is the UEFI's role in the boot process? It runs your application, initializes and coordinates hardware components, and connects to the internet. Of course, it's B. It initializes and coordinates hardware components. Power on self-test or post. Whether your programs with whether required hardware is present and working. This is what post is. You connect it to the internet. No internet connection is needed when you start your machine, by the way. How does UEFI know which device to boot from? It randomly selects a storage. No. Configured boot priority list. Yes. Always boots from the newest device. No, that is incorrect. Follows a configured boot priority list, which is the boot order that we talked about. And then initiate the bootloader. What does the bootloader do? It loads the operating system to the RAM. Right. Check order. Not quite right. Try rearranging the steps. Oh, sorry. Arrange the boot sequence steps in the correct order. So initiate bootloader, firm power on self-test, press the power button. Once you press the power button, you have your select boot device, initiate bootloader. So I guess you would do a firmware and then a post and then initialize or select the boot device and then bootloader. There you go. PC successfully started. Cool. All right. Check. We have the correct answer and then the conclusion. We have covered the core components of a computer system and how it boots up. At the moment, you won't realize this, but further on, when learning cybersecurity concepts, you will often need to recall the function of each of these core components and how they interact with each other. The boot process is a very important concept later on, as it is sometimes targeted by hackers. Now that we know the insides of a computer, the next step is to see how different combinations and specializations of these components lead to a diverse types of computer systems. Continue to the next room. Computer types coming soon to find out. What do you mean coming soon? Is it not on already? Oh yes, we do have computer types. Okay. So thank you for watching this video. I will keep each lab in its own video so that way you don't get overwhelmed. Thank you for watching the outro of every video. Give me a like, give me a subscribe, give me constructive criticism, things that you want to see or things that you don't like seeing in my current videos. All I'm trying to do here is make this a comprehensive knowledge base of, well, knowledge for the community, because I learn from the community and all I'm trying to do is to give back to the community. Thank you for watching and I will see you in computer types. See ya.